Okay, welcome back. This is a continuation of lesson 10. So there's already a lesson 10 part 1 that hopefully you've watched and kind of gotten some basics about solving equations. And now we have 3 more examples to go over from the same lesson 10 PowerPoint. Now we're going to learn about how to eliminate fractions and decimals. So I'm going to actually take us back a few slides just to remind you about the steps we're following. Okay, right here on this slide that says multi-step equation, steps for solving, we're going to focus on really step 1. And actually, I'm just now realizing it just says eliminate fractions. It should really say eliminate fractions and decimals. Fractions are going to be the harder type to deal with because we have to find common denominators, but we're about to eliminate decimals as well in our next example. So that's the step we'll be focusing on. And then the rest of the steps will still be used depending on the problem. All right, so here's number 3 in this set. Again, because the part 1 video, we had already gone over the previous problems. So there's a little note at the beginning saying multiply both sides by 10 to clear the decimals. When we say clear the decimals, we mean eliminate the decimals or get rid of them somehow and end up with just nice integers. Okay, so here's the equation. This is number 3. 0.7y minus 0.4y equals 1.8. So the reality is you don't have to clear the decimals at all. If you are fine dealing with decimals as they are and adding and dividing and everything, then that's fine. But sometimes it's a lot easier if we can clear the decimals. So here's how we can do that. We can multiply by 10. Now, when we multiply by 10, because we're using what's called the decimal system, if we look at the word decimal, without going too far into a whole language lesson, DEC, that has to do with 10. So everything's all about powers of 10 in the decimal system. Decade, that's another word that starts with DEC. 10 years. The month of December used to be the 10th month of our year. It's now the 12th month. Anyway, I digress, but it's all about powers of 10. So if we multiply by 10, what we get to do is move our decimal over 1 place. If we multiply by 100, then we would move it 2 places. By 1,000 would be 3 places, etc. So let me show you what this looks like. Okay, so I'm going to multiply both sides of the equation by 10. So I'm just going to put the entire left side of the equation in parentheses and then write a 10 on the outside. And then the right side, which is just 1.8, I'm also multiplying that by 10. Now this 10, I'm essentially distributing it throughout the whole problem. So 10 times 0.7y, that 0.7, the decimal moves, and it now becomes 7y. 10 times negative 0.4y, that negative 0.4 just becomes negative 4. Again, because when you multiply a decimal by 10, you get to move the decimal point 1 place to the right. So here's what I've written so far. As I'm distributing the 10 on the left side, instead of 0.7y, I've written 7y. Then I'll write a minus, and then instead of 0.4y, I'll just write 4y equals. On the right side, 1.8 times 10, if I just move that decimal over once, I get 18. Okay, and see, in my opinion, it's a lot easier now. The problem looks more doable, I think. Now we can continue. 7y minus 4y, together on that same side of the equal sign, we can combine those together. 7 minus 4 is 3. So now I have 3y equals 18. And finally, I can divide both sides by 3. 3y divided by 3, the 3's cancel out, y equals, and then on the right side, 18 divided by 3 is 6. So my answer is 6. And then, just like we've been doing, I can check my answer. So we'll check. 0.7 times 6 minus 0.4 times 6 equals 1.8. Okay, so let's simplify. 0.7 times 6, that will be 4.2 minus 0.4 times 6, that's 2.4, equals 1.8. And then I'll simplify more on the left side. 4.2 minus 2.4. Just writing that out here. Okay, yes, it is 1.8. So 1.8 equals 1.8. And there we go. All right, so technically in this second unit that we're now in, we are allowed to use calculators. In past years when this course has been taught slightly differently, we were not yet allowed to use calculators. So I'm still trying to approach it where you can do every problem without ever needing a calculator. And so please try to follow this example of here's how thorough I want you to show your work. Okay, calculators are great for checking, but I want you to kind of use it as sparingly as possible. And we'll use them even more in our third unit. All right, good. So the idea there was we cleared the decimals by multiplying everything by 10 first, and then we ended up with just integers. Now, if you don't clear the decimals, that's fine. There's another way to do this problem without clearing the decimals. So I'll just show you that quickly. Back to the whiteboard. Because you might feel like you don't need to. You don't need to clear the decimals. Maybe you're good with how it was. So 0.7y minus 0.4y equals 1.8. If you want to just leave the decimals, that's fine. 0.7y minus 0.4y, that's now 0.3y equals 1.8. Then you can divide by 0.3. Okay, so the 0.3's cancel out, y equals. This is now what I think is a trickier part, the 1.8 divided by 0.3. So when I write that out using long division, 1.8 divided by 0.3, I'm going to move the decimals. So this gets back to long division with decimals that we've seen just a little bit in our previous unit, I think. I'm going to move the decimals over. So remember how I said we weren't moving the decimals? You kind of need to do it here when you're doing this very last step. So it's going to happen one way or the other. But as I'm moving the decimals over, this problem essentially turns into 18 divided by 3 instead of 1.8 divided by 0.3. And we still get 6 for our answer. Okay, so if you'd rather do it that way, that's fine, and just save the moving decimal points for the long division step, that's fine. Okay, let's go back. So that's an example of clearing decimals by multiplying by 10, and if your decimals have more than one digit after them, you might multiply by 100. Whatever you do, do it to both sides. All right, let's move on. And let's look at some fraction questions. So number 4 and number 5 coming up, we're going to multiply both sides by the LCD to clear the fractions. Once again, you don't have to clear the fractions, but if you don't, you have to just kind of carry on and do all your calculations with the fractions still there. I hope what you'll see is if you use this very first step to clear them, to get rid of them, I think it'll be a little easier to finish the problem. All right, so for this first one, this is number 4, negative 5/3 x plus 2/3 equals negative 11. When we talk about multiplying both sides by the LCD, you're going to look at the entire problem as a whole. Any fraction that you see, you need to take that into consideration and find the common denominator of all the fractions. Now in this problem, there's 2 fractions, and they actually already both have the same denominator of 3. So our LCD is 3. Now, I cannot combine the fractions. That's not what we're talking about. We're talking about multiplying both sides by the LCD. So, just like we distributed the 10 before, now I'm going to distribute 3. So I'm going to put the 3, I'm putting the entire left side in parentheses and putting a 3 on the outside, and then the entire right side in parentheses, it's just a negative 11 in this case, and multiplying that by 3. And then when we distribute the 3, what's going to happen is those 3's in the denominator, those will cancel. Now I'm going to write this one in just a little bit more detail because there's a little bit more going on. So here we go. All right, so what I'm writing is 3 parentheses, and then in the parentheses, negative 5/3 x plus 3 parentheses 2/3. Now the parentheses is just, I'm about to multiply. I'm just kind of breaking it down here. And then equals on the other side is -11 times 3. All right, let's actually multiply by 3 now. Remember, the whole point in doing this is to clear those fractions. So in our next step, the fractions should be canceled out. All right, so let's start with 3 times -5/3. We'll put the 3 over 1 so you can see that the 3 that we're multiplying by is really in the numerator of its own little fraction, 3 over 1. And that means that 3 will cancel out with the denominator of 3 in the 5/3. So in other words, cross out the 3's. So you're left with just -5x over 1, or just -5x. Plus, now our next little multiplication is 3 times 2/3, put the 3 over 1. Once again, the 3's cancel out, and it's really just 2 over 1, but I will write 2. Equals, now on the right side, nothing's canceling, you're just multiplying. -11 times 3 is -33. So look how much simpler this is now. We're not done, but the fractions are now gone, they're eliminated. Okay, so what happened is our common denominator was 3. We multiplied every single term in the problem by 3. You're essentially distributing that 3 throughout. Again, to keep the equation balanced. Whatever we do to the left side, we're doing to the right side. And with each of those fractions, the 3's canceled. So we're left with -5x plus 2 equals -33. Let's keep going. We're going to subtract 2 next on both sides. So I wrote -2 on both sides. Crossed out the 2's, plus 2 and -2 cancel out to 0. So on the left side, we have -5x equals. Now we'll combine what's on the right side. -33 minus 2 is -35. And finally, our last step, we'll divide by -5 on both sides. -5x divided by -5 cancels out. -35 divided by -5 is now +7. Okay, +7. Actually, let me move that over here. Let's see if I can check it on the same slide. So we're getting x equals +7. Now let's check. So we'll take that 7 and plug it into the original problem. So -5/3. Instead of x, I'll write 7 and then plus 2/3. Equals -11. So I'm just checking right now. All right. So -5/3 times 7 plus 2/3 equals -11. Let's simplify. So -5/3 times 7, I'll put the 7 over 1. It really becomes -35 over 3 as I multiply across. -5 times 7 is -35, 3 times 1 is 3. So -35 over 3 plus 2 over 3 equals -11. Now I'll continue simplifying. -35 over 3 plus 2 over 3, that's -33 over 3. And look at that, -33 divided by 3 is -11. So -11 equals -11, and it checks. So the main idea that I want you to get from this is we had 2 different fractions in this problem. They both had a denominator of 3. So that was our LCD. We used the LCD to clear the fractions. So we found the LCD, common denominator of 3. We multiplied both sides by 3. And then we were able to cancel those denominators. All right, let's do one more fraction problem. Here's number 5. 3/4 x plus 3/8 x equals 45/8. Okay, there's 3 different fractions here. They do not all have the same denominator. The bigger denominator is 8, and 4 goes into 8. So what we can do is we can use 8 for our common denominator. So I'm just writing a note, LCD equals 8. What I'm going to do next is multiply both sides of the equation by 8. And this time, I'm going to just immediately write parentheses around each term and multiply each term by 8. This is saving me just a little bit of rewriting that I had to do before. So I'm kind of, again, I'm basically distributing that LCD. I'm distributing that 8. I'm multiplying it by every single term in the problem on both sides. And remember, the goal here is to clear our fractions. We are expecting, after all this kind of messy multiplying and canceling, we're expecting our fractions to be gone. So let's take a look. I'm actually going to start on the right side because I think it's a little easier on the right side this time. So let's take a look at 8 times 45/8. This is on the right side of the equation. The 8's will cancel because 8 divided by 8 is 1. So this is essentially just 1 times 45, which is 45. So 8 times 45/8 is just 45. That's what's on the right side of my equal sign. So I've written 45, then I've written an equal sign. I'm moving towards the left, kind of working in backwards order here. I'm now, here's what's on the other side, 3/4 x plus 3/8 x. I'm going to work on the 3/8 x. So I've multiplied it by 8. 8 times 3/8. I'll just write this off to the side. 8 times 3/8. It's really like 8 over 1 times 3 over 8. The 8's cancel. You're left with just 3 over 1 or just 3. So long story short, just cross out those 8's. And then you're left with 1 times 3x, which is 3x. Now there's a plus sign to the left of that. And finally, now I've made it back to the first term. I saved that one for last because it's just ever so slightly trickier. Okay, so the very first term in our problem was 3/4 x, and I've multiplied it by 8. So 8 over 1 times 3/4 is what we need to work out. This time it's not just a matter of, oh, cross out the 8's. There's not an 8 down there in the denominator, it's a 4. But luckily, 4 does go into 8, so we can still do some canceling here. 8 divided by 4 is 2. So watch this. When I divide each of these numbers by 4, 8 divided by 4 becomes 2. 4 divided by 4 becomes 1. So 8 over 1 times 3 over 4, I can kind of rewrite it as 2 over 1 times 3 over 1. It's really just 6 over 1, which is 6. So what that means is I can just write 6x for that first term. Okay, that's a lot. It's easier from here to the end of the problem. So once again, here's what we did. We looked at our 3 fractions. They had denominators of 4, 8, and 8. The common denominator is 8. I'm multiplying each term by 8. In each case, the 8 canceled out the denominator. With the first term, the 8 divided by 4 is 2, and then 2 times 3x now is 6x. That's my first term now, 6x. Plus, with the second term, 8 times 3/8, now that becomes just 3, so my term is 3x equals. On the other side, 45/8, when we multiplied that by 8, the 8's canceled out, and we're left with 45. So here's where we are, 6x plus 3x equals 45. Okay, I was almost ready to subtract 3 on both sides, but we don't really have 3, we have 3x. So what we get to do actually is combine like terms. 6x plus 3x is 9x. So I can rewrite 9x equals 45. And then we'll divide both sides by 9. The 9's cancel out. X equals 45 divided by 9 is 5. So x equals 5. Okay, let's now finish up by checking our answer. We're going to check by plugging in 5 for x. So here's our check. Okay, 3/4 times 5 plus 3/8 times 5 equals 45/8. That's what we're checking to see if this is true or not. So with each of the 5's, I'll put it over 1. 3/4 times 5 over 1, that's 15 over 4, plus 3/8 times 5 over 1, that's 15 over 8, equals 45/8. Okay, so I can't really tell if I got it yet. Let's work on adding 15/4 plus 15/8. I need to get a common denominator, which we know is 8. This time I'm actually going to change my first fraction to have that common denominator. So what I'm doing next is working on this 15/4. I would like it to be over 8. So I'm multiplying by 2 over 2. 15 times 2 is 30. 4 times 2 is 8. So I have 30 over 8 plus 15 over 8. And yes, it looks like we're on our way. So 30 over 8 plus 15 over 8 equals 45 over 8. And yes, that's true. I'm just about out of space here. 30 plus 15 is 45. And yes, they have the same denominator. So we're getting 45/8 equal to 45/8. It works out. So again, that was just our check that our solution worked. All right, so this is a part of this lesson that you could probably work on for quite a while, practicing clearing those fractions. The fraction and decimal questions, especially the fraction questions, tend to be the ones that I get the most questions on as students are working on homework. So come back to these examples as you need to, and I'm sure there's others on the homework that maybe are different enough that you might have some questions. So as always, please ask for help, and please show up to our Tuesday class meetings, and I will definitely be sure to show at least 1 or 2, if not more, examples of these types of equations. The good news is, as we move on to lesson 11, it's a continuation of this, and so we'll see more fraction questions there, so it'll be a chance to get better. So this is the end of lesson 10, but I do want to tell you that lesson 11, again, kind of picks up where we're leaving off. So feel free to be done now. I'm just going to give a tiny little preview because it's the same PowerPoint for me, at least. Lesson 11, this is what we'll get to next, equations with variables on both sides. Just kind of showing a little preview here, and see, here we go. You'll see some more fraction questions where you'll find an LCD and multiply both sides by the LCD. Okay, and here's number 6 with decimals. And then we have some more distributing and some more fractions as well. So, okay, good. I'll end here and just stay in touch, and I'll see everybody soon. Thank you.